Hi guys, this is Alexis O'Connell, and today we're going to be talking about the momentum principle. It's going to be a short little example that we're going to be talking about space and a space capsule that's trying to enter the Earth's atmosphere. And so what we're given, well, here's the space capsule and it's trying to enter the Earth's atmosphere. Here's the atmosphere, and here's the Earth. And we're given these values: the initial velocity, the final velocity, the force that the capsule exerts back from its rockets, and the mass of the capsule. And we're asked to find the time for how long must they fire the engines in order for them to slow down from 2.6 times 10 to the 4th meters per second to 1.1 times 10 to the 4th meters per second to enter the Earth's atmosphere. So in order to solve this problem, we have to use the impulse momentum theorem, which says that the force, which we're given, is equal to the change in momentum over the change in time. And we can find the change in momentum by using the values given: mass, final velocity, and initial velocity, because change means final minus initial. And the mass is held constant because we're told to ignore the change in mass after the rockets are fired. If we were to know, the mass of the fuel, we would be able to figure out that, but it would be a much harder problem. So we have to know how to find the change in momentum. So if we just plug in the values here, we know that the mass is 3,800 kilograms, and final velocity minus initial velocity. So we just plug this value into the calculator, and we get negative 5.7 times 10 to the 7th kilograms, and that's the change in momentum. And if we do a little algebra, we can rearrange this problem to solve for change in time, which we're looking for, because we know the force. So we know that the change in time is equal to change in momentum over the force, and the change in time is equal to 5.7 times 10 to the 7th kilograms per second over negative 1.8 times 10 to the 5th newtons. And we can cross out these values to give us seconds, and that will give us 316.66 seconds. And that's how much time that the capsule must run its engines in order to slow down. Thank you.